All right, this should look familiar to everybody. This is one of your slides from the Desmos activity. It has all three of the sliders, so you can control each one of these variables in the absolute value function. Okay, y equals a to the absolute value of x minus h plus k. Okay, we'll talk about why this negative or this minus sign is here for h and why this plus sign is here for k. Okay. First thing that you guys started to mess with was the k value. Okay. When we start to let this go around, you'll notice that it goes up and down. As it gets more positive, it goes higher up on the scale. As it gets more negative, it gets lower down on the scale. Okay. This one's pretty straightforward. The plus is indicating that if it's positive, it'll go up in the positive direction. If it's negative, it'll go down in the negative direction. It's going to follow exactly whatever this number says. And you can see the direction it's moving, since it's going up and down, it is moving on our y-axis. Okay? This is going to help us find our vertex, our turning point, and help us find what our y value is for that turning point. If you look, you'll see right here we have a y value of 1.5. Set this back to 0. The next one that you did was the h. Now, we had that minus sign there at the h. What you'll notice here is that as it gets positive, it's going to the positive, and as it's going negative, it's going to the negative. However, we're saying that this is minus 1.33. Okay? If I go up here and I change this to a plus, what you'll notice is as it gets more positive, it's getting negative. As it gets more negative, it's getting positive. Okay? When we're dealing with these equations, how you're going to see it is x plus 4.25. However, how that relates to your graph is that your vertex is now at negative 4.25. That minus sign that's originally in the equation is to let you know to take the opposite of whatever that h value is in there. Okay? Take the opposite. All right, let's set this back to 0 again. And then finally we had the a. A acts like our slope. It's a little different though if you remember from class that if you're graphing this, what we're going to do is find the vertex and then follow the slope up. Right now it's at 1, so we're going up 1 over 1, up 1 over 1. As we let this go, you'll see as it gets bigger, it gets steeper, it gets to be like a sharper point. As it gets to be in the decimal range, oops, a little too much. As it gets to be in the decimal range, you see it widens out. It gets fatter, it gets flatter, okay? At 0, it is a completely flat line. But if we let it go negative, it happens the same thing, where if it's a big number, it gets pointier, except for now it's pointing downwards, okay? Every single value is going to be negative here. And that's because the absolute value makes everything positive that comes out. But if we take a positive times a negative, it's always going to be facing downwards. Okay? Now, let's look at a few examples of how we graph these. Let's start with what we were talking about. Let's start with just doing the k function. So let's say we had the equation y equals the absolute value of x plus 1. Okay? What we want to do is we want to look at our k value, and we usually want to look for our h value. If our h value is not there, then it's a 0. Okay? If you don't see anything in the bars, it's a 0. K is our number outside the bars, and that one's just a 1. And remember, we're just going to keep this one the same. So what that means is what we have to do is start here. This is our vertex. And then we're going to follow our slope. Now, just like how I started off showing the parent function on the video, I had a set to 1, okay? That is what is in front of here. It has a slope of 1. If you multiply anything times 1, it stays itself. And remember, this is 1 over 1, which means I'm going to go up 1 over 1 from my original point. And honestly, that's enough for me to create half of my absolute value. Now, if I want to create the other half, I just go back to my vertex, my big point, and I'm going to go up 1 over 1 in the other direction. For the absolute value, all you need is 3 points. The vertex, and then at least 2 points following the slope. And then you can connect those with a straight line. Okay? Now, let's say we have one where we have a number inside the absolute value bars. Okay, let's look at 2 of these, actually. They're going to be very similar. But you can see one has a plus, one has a minus, okay? So the function that I wrote in black here has a -3. But if we remember from what I showed you in the video, for h values, we need to take the opposite, okay? So here our vertex is going to be at 3, 0. Opposite inside the bars, the same outside the bars. And since we don't have a number outside the bars, again, it is 0. Down here, we're taking the opposite inside the bars, and we are leaving the outside 0. Now, these are x values. You're going to write these on the line for x, okay? So let me put this one here first, because I have blue open. So there's my blue graph, the vertex for it. And here's the vertex for my one I drew in black here. And you can see that there's no number in front, so again, the slope is 1. So up 1 over 1. Up 1 over 1. So there is y equals x minus 3. And there is y equals the absolute value of x plus 3. Okay? The reason this occurs, that it does the opposite, is because what you're doing is you're finding the smallest value that can come out of this. And the smallest value that can come out of this is whatever makes this 0. Okay? So positive 3 would make this 0. Negative 3 would make this 0. That is why this flip occurs. Okay? So I have I have one more thing I want to show you, and then we're going to look at one more complicated one. All right, so we have 4 ways we could see A done. Okay, we could see this way. We could see that 4 being negative. We could see that 4 positive, but inside the absolute value bars. Or finally, we could see that 4 being negative and also inside the bars. Okay? All of these look slightly different, but I'm going to give you a little hint. Most of these are the exact same thing. Okay? Let's start with the green one. The green one, notice there's nothing inside the bars or outside the bars for all of these. So all of these are going to have the vertex of 0, 0, right in the middle. The origins, we call it. Okay? And this one has a slope of a positive 4. So positive 4 tells me that I'm going to go up 4 and over 1. Okay, 4 over 1. Up 4, over 1. Okay? Now, the red one here looks just like the top one, but we threw a negative sign in front. Okay? This one also has a vertex of 0, 0. However, that negative 4 is telling me to go the negative direction of rise. Okay? Remember, slope is rise over run. And if we want to do a negative rise, we're basically going to fall. We're going to go down 4. 1, 2, 3, 4. And we're still going to go over 1 because it's still over 1. So what we get here is basically a mirror image of the positive version. Okay? It looks exactly the same, it's just going downwards. Alright, so let's look at these other two. So when we have things being multiplied by each other inside the absolute values, we can actually separate them. Okay? As long as we have what we call a greatest common factor. Since there's only one term here, we can take out that 4. We just have to make sure we take the absolute value of both terms here. Well, the only thing we can really figure out right now is the absolute value of 4. And the absolute value of 4 is 4x. Oops. 4 times the absolute value of x, which is exactly what we drew in green here. Now when we get down to blue, we can do the exact same thing. We just have to make sure we remember our negative inside that absolute value. Okay. Now, what is the absolute value of negative 4? It's positive. This is the exact same thing as a green one too. The only time when you have an A and it's going to be facing downwards is when the number outside the bars is negative. If the number inside the bars is negative, it's still going to turn into a positive. All right. I got a complicated one for you now. Let's say we have something like this. Y equals negative 3x plus 3 minus 4. Okay, this one does not look like our a times the absolute value of x plus h plus k. It doesn't look like this, but we can manipulate this to look like it. All right, we can actually use these bars like parentheses. And if you remember from Algebra 1, we can actually factor out a common factor from here. What I'm going to factor out is a negative 3. Okay, I'm going to factor out a negative 3. The only thing that's different here is now I have to make sure when I factor out that negative 3, I keep it in absolute value bars, because technically I'm factoring out the absolute value of negative 3. And one more thing, remember, if I'm factoring out a negative from a positive, it flips it, okay? It becomes a negative. So what this will turn into is the absolute value of 3, or negative 3 is 3. The bars stay the same. And the outside I haven't touched. Okay? There. Y equals a times x minus h plus k. Here we can see we need to take the opposite. My vertex is going to be at positive 1, negative 4, and my slope is 3, or 3 over 1. Okay, so when I graph this, I'll start at 1, negative 4, okay, and then I'll go up 3, 1, 2, 3, and over 1. Go up 3 and over 1. Okay? We're going to be practicing this next class, so please watch this video carefully, and if you need to rewatch it and try out at least some of the manipulating of the problems, please do so. All right? Have a good weekend, guys.